Our next speaker is Rosa. Melissa has over a bachelor's degree and a master's degree and over 10 years of experience at the intersection of climate science and policy, working in really a lot of different applications of geospatial information, and really has applied it across all sorts of environmental disciplines. She went to the Conference of the Parties this year, which is an annual meeting set up by a United Nations Convention that was passed in 1992, and learned quite a lot about international policy there. And her project is super interesting because it presents an opportunity where two nations have a common interest in a specific region and an opportunity to cooperate on a specific policy matter. And if cooperation on a small scale is possible, why not larger scales? So it has to begin somewhere. And the kind of work Melissa is doing is the kind of work that we need to all be thinking about more broadly to solve this problem. So it's a pleasure to introduce Melissa. The floor is yours.
Great. Thank you so much, Corey, and hi, everybody. I am Melissa Rosa, and today I'm going to be talking about my project, which is a binational climate vulnerability assessment for the San Diego-Tijuana region. And this has been really a fascinating region to focus my project on. You know, it's home to millions of people. It has a diverse economy, is an internationally recognized biodiversity hotspot, and really where a developed and developing country come together. And climate change just adds another level of complexity to the region. So full disclosure though, while this image shows wildfire smoke, I won't be talking about wildfire today, even though it was included in the assessment, but I chose to show this photo because it shows the region collectively experiencing a climate-related event, which was the goal of this project. But first, a little bit of background. Yes. Okay. So the San Diego-Tijuana region has been an area of concentrated economic growth that has driven rapid population and urban expansion over the years. As you can see in this map, most urban areas are located where watersheds drain into the ocean. And the removal of vegetation due to urbanization has disrupted hydrological patterns, degraded natural ecosystems, and increased wildfire risk as urban areas extend into wildlands. This has also contributed to a significant amount of environmental hazards on both sides of the border. So for example, in Tijuana, inadequate housing and stormwater infrastructure has contributed to landslides during heavy rain events, often in poor, highly vulnerable neighborhoods. And the inability to capture this runoff and sewage also can bring pollution trash to San Diego, which has prompted beach closures in the past. And this is not a new issue. Here's an article from the Washington Post last week that does a fantastic job articulating the long history of the problem, which goes back to Prohibition. My favorite quote from this article is that we must understand the southbound capital flows and the northbound sewage flows are two parts of the same story. And then, you know, the added layer of climate change experience in the region will only worsen these existing environmental problems and amplify social justice implications. So while climate vulnerability assessments and adaptation planning have taken place in this region, these are often confined to jurisdictional boundaries and do not consider the region as one social ecological system that will disproportionately experience climate change together. So the objective of this project then was to conduct a binational climate vulnerability assessment for the San Diego-Tijuana region and present results in the form of an atlas that can serve as a public resource for cross-border climate adaptation planning. The atlas provides recommendations with local examples, specifically nature-based climate solutions that can help restore degraded ecosystems and increase urban resilience. And this was done by reviewing methods from existing vulnerability assessments, gathering geospatial data sets available on both sides of the border, and synthesizing social, structural, ecological, and climate information into one binational climate vulnerability assessment. So I'll note that, you know, most of the maps shown in this presentation were ones that I made and will be included in the atlas. To examine the geographic variation of social vulnerability, a binational social vulnerability index, or BSVI, was calculated using US and Mexico census tract data sets. Socioeconomic variables were selected covering several categories such as poverty and employment. And these were chosen based on variables that are included in relevant existing indices that had been calculated for the US. Variables were individually ranked 1 through 5, then the variable ranks were weighted equally to calculate the geographic mean. Whoops. So due to the multiple benefits that green spaces provide in the context of climate adaptation, this project looked at the relationship between green space and social vulnerability at the census tract scale. The Normalized Difference Vegetation Index, or NDVI, is a common remotely sensed data set that is used as an indicator of greenness. So NDVI values were used to calculate the percent of greenness in each census tract. And then a bivariate floroplex map was used, or is a map that maps two variables at once, and that was created as a visual tool for illuminating areas with high social vulnerability and low vegetation cover. So the climate projections and impacts focused on extremes, covering heat waves, intense rainfall, as well as sea level rise and wildfires. But in the interest of time, I'll only show a subset of climate results, and you can refer to the report or the atlas for more information if you're interested. So downscale climate models show that an increase in average annual temperature is expected to increase the intensity of droughts. In addition, the frequency of days with heat waves are projected to increase between 20 and 50%, an average increase of 5 degrees Fahrenheit by mid-century. The impacts of drought and heat waves include water shortages, urban heat islands, and other impacts listed here, and that Maren also talked about earlier. The map on the right shows spatial distribution of heat wave temperature projections, and temperatures are noticeably higher in Tijuana as compared to San Diego, which may be due to the San Diego Bay that contains water with a higher heat capacity. Or if you look back at the NDVI image, you'll notice that there is more vegetation cover shown in more of the greenish tones here in San Diego as compared to Tijuana. As the climate warms, models show that while annual precipitation patterns will shift to a wetter winters and drier springs, extreme precipitation will also intensify. The average wettest day of the year, which represents extreme precipitation, is projected to increase up to 23% by mid-century. So this map on the right shows these projections and indicate urban areas will experience a lower increase in extreme rainfall compared to rural areas, which may also be influenced by land cover. But as you saw the slide in the beginning, water primarily flows from these rural to urban areas near the coast. So increased runoff and flooding is projected to occur throughout the region, leading to more erosion and other flood-related impacts listed here. So the BSVI results, they mostly align with overall spatial patterns of known socioeconomic characteristics in the region. The map on the right shows the vulnerability ranking, where dark red equals highest vulnerability and dark blue is lowest vulnerability. So in San Diego, the downtown center and affluent coastal communities such as Coronado and La Jolla show a low vulnerability, while El Cajon, South Downtown neighborhoods extending southward towards the border show high vulnerability. In developing countries, the inner ring is typically the hub of the city that consists of a more wealthy population, as seen here in Tijuana. However, discrepancies between these results and known socioeconomic patterns do exist in areas such as Southeast Tijuana. The BSVI shows medium vulnerability here, but these areas consist of poor, disadvantaged communities that are relatively young. They live in substandard housing with dirt floors, no electricity, no sewer connection. So this underscores the challenge of combining census surveys for two countries with different definitions of vulnerability or poverty, and suggests that the BSVI calculation requires further refinement and consultation. So the bivariate map you're about to see combines the Binational Social Vulnerability Index with vegetation cover, which was the percent green from the NDVI image census tract. So in San Diego, downtown areas with medium to high social vulnerability tracts and low vegetation, so the dark purples, are primarily seen in high density areas such as National City, Chula Vista, and Imperial Beach, as well as El Cajon. And while low vegetation cover is often associated with low socioeconomic status in both developed and developing countries, this is not necessarily the case in Tijuana due to limited water availability, as you can see here in Las Playas. So considering that vegetation in urban areas can reduce air pollution and impacts of high temperatures, most urban neighborhoods in Tijuana, despite socioeconomic class, can be more exposed to environmental and climate hazards than San Diego. But again, the BSVI needs refinement, but this takes us one step further towards looking at the relationship between social and ecological systems at the binational level. Okay, so what I'm about to discuss here come from the California Fourth Climate Change Assessment and Bending the Curve, which is a report developed by the University of California that outlines solutions for carbon neutrality. And these recommendations were selected to elevate key strategies for climate adaptation planning from a binational perspective. So here I'm highlighting several recommendations that we often hear about, including partnerships and collaboration, governance, and science and data sharing. I go into more detail for each one of these in the report, but to save time, the recommendation I'm presenting today provides examples of looking to nature as the inspiration for climate action. So these recommendations from Bending the Curve underscore the importance of protecting and restoring natural ecosystems to improve ecological connectivity and also carbon sequestration across the landscape. And in addition to climate mitigation, I would add that natural climate solutions allow cities to address adaptation simultaneously and help bring cities to life by bringing life back to the cities. The built environment is constantly changing, which can provide many opportunities to implement green infrastructure projects, such as expanding tree canopies to reduce urban heat island effects, or planting native vegetation to help anchor soil and minimize erosion during heavy rainfall. So to illustrate how this plays out at the local level, here's a map that highlights the hydrological connectivity and flood risk of a binational watershed. The map shows where Los Laureles Canyon, which is an informal settlement in Tijuana, drains to the north into the Tijuana estuary in San Diego, bringing eroded sediment that buries sensitive habitat already threatened by climate change. The map also highlights two different types of flooding for a 100-year storm: widespread flooding that extends across the landscape in the estuary, and pluvial flooding in Los Laureles, which is fast-moving floodwaters that develop quickly during intense rainfall. These can be life-threatening because many people live adjacent to steep slopes and running rivers of debris, which destabilize these slopes, causing landslides and destroying homes. So the ability to preserve the remaining open space and restore native vegetation in the canyon will not only directly influence river flow events and sediment input in the estuary, but also protect vulnerable communities in Los Laureles Canyon. Protected areas or special zones already exist in the canyon. These were established by law in 2004, but they largely focused on the upper basins, A, B, and C that you can see here, because they were more vegetated at the time and more suitable for development. However, rapid development still occurred throughout the canyon because environmental regulation was rarely enforced. So this is why the UCSD Center on Global Justice has proposed to implement pilot projects in vacant and neglected parcels that can create an open space network and act as public space to educate communities on green infrastructure, better building practices, and native vegetation restoration. And these projects, they build upon an immense amount of background work that has already been done in the canyon. There's a binational council that represents communities in each sub-basin, And there's also cross-border collaboration between social and ecological institutions for the exchange of technical information. So this makes Los Reales a model case study for green infrastructure and establishing conservation areas as binational assets that could transfer lessons learned to similar geographies along the border. So in conclusion, extreme rainfall, droughts, heat waves are all expected to intensify with climate change, and communities in San Diego and Tijuana will experience this change with different pre-existing vulnerabilities and capacity to adapt. The Binational Climate Vulnerability Assessment and the Atlas developed through this project can serve as a public resource for policy outreach and for cross-border climate adaptation planning. And while more work certainly can be done to address limitations such as the Binational Social Vulnerability Index, in order to conduct a more in-depth assessment, this project touched on some of the pressing issues and salient points. And I'm also fortunate to say that I am able to continue this work over the summer with the Center on Global Justice, and we'll build upon the Atlas to turn it into something that can be shared widely. So with that, I'd like to thank my amazing Capstone committee for the inspiring work that you do, and to all those who have provided me with valuable research support along the way, as well as individuals from organizations noted here who have provided expert guidance or spatial data needed for the Atlas. So thank you very much for listening, and I'll take any questions, or you can email me later as well.
Great job, Melissa. Excellent. We're going to open the floor to questions. So again, for anyone who's joined, please see the Q&A icon at the bottom of the screen to type in your questions directly to Melissa. We have a couple here that are waiting for you. The first one from Bridie Scully asks, nice job, Melissa. What do you see as the biggest challenge for you within this project?
Oh my gosh. Well, Bridie, you know, it's really been the data. You know, finding the same level of data sets on both sides of the border was really challenging. There's a wealth of data information that's available for San Diego, but that was not the case in Mexico. So I really needed to leverage, you know, my connections and partnerships, and you know, to be able to reach out to people in Mexico, researchers, in order to find the data, because it wasn't as readily accessible as it was in the U.S. And also, I'll add on to that, you know, working with census data is really challenging. I'll never underestimate the amount of time it takes to work with those data sets and get them into proper working forms, something I can analyze. So yeah, data is always a challenge.
Absolutely. Our next question is from Angelica Rodriguez, who says, excellent work. As both a scientist and South San Diego resident, I really appreciate the cross-border perspective you are demonstrating. What stakeholders will be able to use this important assessment?
Yeah, good question. So really what we're trying to do is, you know, make this something that's a public resource so that, you know, anybody can use, whether you're someone who works on policy or someone who works in planning, someone who works in communication, because really the ultimate goal was to be able to show this, you know, climate vulnerability in the region as something that's being shared collectively. And that is something that you just don't see very often. So really all stakeholders, I think, could eventually benefit from this.
Excellent. If there are no other questions, we'll give it a minute or two. Otherwise, thank you so very much. That was fantastic, Melissa. Thank you.
Thank you.